Now, we would like to welcome one of the scientists who has been involved from the beginning. His name is David Avila Roldán. He's an engineer and an expert in metallurgy. He manufactures car parts. He manufactures parts for aircraft. He manufactures parts for railroad, and he's got 50 years of experience. He's an expert in the field that could tell us about the thickness of the sphere. And he's got specific results. He's got the results of the temperature tests that were made on the sphere as well. Welcome.
Okay. David, go.
Thank you very much. Good afternoon to all of you. My name is David Avila Roldán. I'm a chemical engineer from Mexico's Metropolitan University. And I'm going to talk about the physical evidence and the tests that were made. They're non-invasive tests that we realized. It's important to mention this. Can we have the images on screen, please? Go ahead. So the main objective of this research and the tests that we conducted is to identify what type of technology was used to fabricate this sphere. And we need to know about the materials, as Engineer Garrido anticipated. We already evaluated this. We already did this verification in labs of the university, but we also did it here as well. I would like to clarify that each of these tests were done preliminarily, previous to and after that, the university were more specific to details that we recommended. We also need to know what techniques, what manufacturing techniques were used to create the sphere, as well as the different tools. So we came up with an experiment with 13 different studies and 3 additional ones to prove the results, to prove the hypothesis that we had at the beginning. The radiation, the nuclear energy radiation, gave us 0.12 cybers per hour. This means that we have no trouble at coming close to the sphere. It's not dangerous because it's way below the levels of what might be dangerous radioactively speaking by other organizations. We also measured the electrical field, and the result was 0 volts per meter. We also measured the influx, the magnetic influx, and the result of measuring magnetic influx was 0.0 microteslas. That means that there is no electromagnetic energy that is being emanated from this sphere. We also did a preliminary analysis on the physical traits because it's necessary to evaluate how it looks, if we want to understand how it was made. So we look at it physically and we found the following. There's a severe porosity in the northern hemisphere.
Wow.
And there's a regular porosity in the southern hemisphere. But we also realize that there's a line or a possible division line between both hemispheres, which is located at the equator. And it's not completely parallel, it's not at the center of the sphere.
Right, okay.
This led us to the following conclusions. As it corresponds to the physical traits when you drain it with sand, because of that level of porosity that we mentioned previously, we consider that that's the process by which it was made. We realized that in the northern in the equator, there are certain points, and they're not made of metal specifically, where we suggested to stop that study right there, and we observed that this was highly relevant because these small dots have a small polymer which is integrated, which has already been confirmed. A lot of the symbols and the writings that you see on the sphere correspond to something that was done by hand. Somebody did it by hand first in order to make the designs that are on the sphere. We still have to study this part even further. In conclusion, we realize that it's not a technology that was expected. Maybe it was done with CNC, or perhaps it was made with some other type of machinery. No, negative. It's done through a simple process, which is also complex at the same time, due to its chemical composition more than ever. I'm going to go into details further down the line. This is what I was mentioning to you previously. What we already saw and talked about. And the chemical composition is of utmost importance because we have a silicate presence. There are high levels of silicates, and the traits that it reflects is that of something that's been through a foundry where the fusion temperature decreases on one hand and the fluidity increases on the other hand. This means that for molds that are hard to use because of their geometry, makes that the material flow perfectly through that mold. Nevertheless, it's not the only trait that we discovered. As a finished piece, it gives it a thermal protection. In fact, it also helps it maintain the electrical arc. Could you please help me with the next slide? Thank you. Regarding chemical composition of copper, we realized that there were certain dots on what appears to be a chip. We realized that it's made of aluminum with a high purity level. Not high purity, because we'd be talking of 99.99%, but without a doubt, with this type of purity, it's used in industry, specifically due to its high electrical and thermal conductivity. They use it to manufacture electronic components in the car industry and in the airline industry as well. Pardon me, we're running a little bit short on time. What are the most important points, the variations that we obtained, the inconsistencies in the hardness? I was there. If we could see the results, please. We got 1 minute left. One of the inconsistencies that we detected is the hardness level. At first, we measured on a scale, on a Brimel scale, and we had an average of 333 units of Brinell units. Afterwards, we tested the magnetic field, and that magnetism caused an uproar. At the lab, we still can't fathom the results. Certain inconsistencies that were made after the magnetic tests were done with certain magnets of 6,000 Gauss, there was significant variations. That is to say, from 333 HB that we originally had, we went to 58 HB. We're also seeing another inconsistency here, which is temperature. There comes a point when it loses stability. The sphere loses stability, and the temperature starts going up instantly from 24 up to 33 degrees centigrade. And we did certain tests, and those inconsistencies led us to think that there's something strange. There's parts where the sphere is stable, like we see it right now. We also measured the temperature of the surroundings. And through the pyrometer, we saw that it was very close to the measurement of that monitor, close to the same results. So there's an instability. It's not that stable in terms of temperature. In this video is exactly when we're talking about these inconsistencies regarding the hardness level. Do we have audio? It varies in its hardness. It's the different inconsistencies in the hardness. Here we have a measurement of 62, and here we have 64. Can you try this other side too, please? When we did the measurements, we have 791, 793, 783. There's a variation of plus minus 3%. But it's within the range, the acceptable range. Now we're doing the magnetic test. There was a high level of hardness, an extreme hardness. Then we did the analysis on iron, and after we approximated the magnets, it came back to its original hardness of 6080 Brenners. Yes, that's the inconsistency that we had regarding measurement of the hardness levels. And this happened throughout how many minutes? Throughout 5 to 10 minutes is how long the test lasted. And the hardness level never became that extreme. That's correct. We have to do further studies regarding this topic, because it could have been two different situations. One was that maybe what's in the inside of the sphere has been interfering with our electronic equipment, because it's hard to imagine, hard to understand that through a magnet the sphere would change its physical properties. So there's two paths that we have to follow there. So its weight increased, and in this case, after you approximated the magnets, the hardness level decreased, which means that what's on the inside of the sphere is directly interfering with the structure of the sphere, which makes it almost alive. We have to verify all this step by step. Within the sphere, apparently there's specific materials of different densities. For example, we ran tests on densities, and we have 0.84 grams per cubic centimeter. And if we use the reference of the density of aluminum, we know it's 2.7 grams per cubic centimeter. This leads us to believe that if this sphere was made strictly from an aluminum, it should weigh approximately 32 point some kilograms.
can change the speed and go places.
What really helped us, Jaime, is the studies that you had done, the X-ray studies and the scanning via tomography, because we detected 3 different elements with different densities.
That's the mechanism inside that rotates and produces the charges. And it's still active.
During the microphotographic study that we made, we realized that there's a perforation as part of the aluminum so that the copper is deposited there and so that it has physical contact with these components which we have no idea what their function is. At the bottom part of the sphere, we see a pattern, a percussion pattern that we see as part of the moons. Only the moons, not the triangular symbols. And the etchings were made with physical tools, made from silicate carbon. And where we have the perforations or the points, this is very important because I said, Jaime, I think we have a polymer here. And with the microphotographic study, it tells us that this polymer is protected. It's coated with an unknown material which we have not identified. Thank you, David. And finally, that would be the fiber optics, right? Yes, that's correct. It was the test done on the fiber optics that led us to these results, which are important. And thanks to that, we were able to make the next step and detect the fiber optics. Thank you very much.